Once a volleyball is served, it experiences projectile motion. In the figure, point A is the serve location. Point B is the location just above the net where the ball passes, and C is the location on the court where the ball lands. If you look at the different H's, the H naught is the initial height of the ball at the serve location. The H max is the maximum height reached by the ball, and the capital H is the height of the net. The V shown is initial velocity of the ball, and the downward G represents the downward acceleration due to gravity.
Larry tosses a volleyball to his friend Litz, who catches it at the same height from which it was tossed. The volleyball travels a horizontal distance of 10 meters and has a maximum height of 4 meters above where it hits. For part A, we use the formula y equals -1/2 gt squared. So the total time of the volleyball in the air is 2 times the seconds, which gives you the total time. For part B, we use the formula x equals velocity initial times time. For part C, we use the formula time equals initial velocity of the y direction over gravity, which can be set as v initial equals time over times gravity. For part D, we use dv equals the radical of initial velocity of the x direction squared plus the initial velocity in the y direction squared. Then to find the angle, we use the cosine squared is equal to velocity of x, initial velocity of x over velocity, which gives us an angle of 57.4 degrees. Acceleration of the projectile is A is equal to gravity, which is equal to 9.8 meters per second, since acceleration of the x is equal to 0.
In volleyball, the application of a force by the hand on a ball directly results in the change in momentum of the ball. This product is called the impulse. Impulse is loosely defined as being equal to a body's change in momentum. It is also defined as the force exerted on the ball multiplied by the change in time. This result is called the impulse momentum theory. Thus, the direction of the momentum will match the direction of its velocity. For example, a middle hitter will have more momentum than a defensive player. This is because she is required to move at much higher speeds than a defensive player. Therefore, the shorter amount of time the player's hand is in contact with the ball, the greater the force applied to the ball will be. The momentum from this approach is already great, so the force will be great if the time is short. This is also evidence to support why the arm swing should be fast. It will lessen the amount of time that the hand is in contact with the ball.
Applying the concept of impulse, what is the impulse that must be imparted to a volleyball with a mass of 0.208 kilograms if it is served at a speed of 15 meters per second? In order to solve this, you must know that the volleyball is at rest, so the initial momentum of the volleyball is 0. The impulse momentum theorem implies the impulse applied to a volleyball is equal to the final momentum. Thus, the impulse is in the direction of the final momentum, and its magnitude equals the final momentum. So the final momentum equals mass times the final velocity. Therefore, the mass of the volleyball, 0.208 kilograms, times the velocity of the final volleyball, 15 meters per second, equals 3.2 kilograms meters per second. Therefore, the impulse of the volleyball is 3.12 kilograms meters per second.
According to the work-energy theorem, the total work done to accelerate the volleyball from rest to speed is equal to the amount of kinetic energy it undergoes. Kinetic energy is defined with the equation K equals 1/2 mv squared. The energy of the motion of the ball is dependent on its speed and mass. Potential energy is stored energy and is equal to mass times gravity times height. The amount of potential energy depends on an object's height from a zero level. A ball being held in the air ready to be served has more potential energy than a ball being held at the waist. When someone is approaching to hit a volleyball, they are instructed to plant and take off quickly. This has to do with the concepts of potential and kinetic energy. During the approach, the player has kinetic energy, and the idea is to transfer it into potential energy. The kinetic energy would be less if one came to a stop, and they wouldn't be able to jump as high. Since potential energy is the product of mass, gravity, and height of the jump, it is important to remember that the height is what determines how much potential energy can be achieved. Potential and kinetic energy are important in many aspects of the game, but especially in the hitting approach.